Hello everyone, Mr. Fawcett here, back with our second lesson at the beginning of our proofs unit. Today we're going to be talking about conditional statements. As always, before we get going with the new content, take a second to work through 4 review problems, pause the video, try the problems, and come back and see how you fared. Okay, so we are saying whether these statements are true or false. So the measure of an obtuse angle is less than 90 degrees. Well, by definition, an obtuse angle has a degree measurement between 90 and 180. So this is false. Number 2 says all perfect square numbers are positive. So perfect squares, these are numbers that you can take the square root of and get a integer, a positive integer. So numbers like this are 1, 4, 9, 16, 25, etc. So on the surface, it looks like these are all positive, but there's one that I conveniently left out, and that is 0. So not all of them are positive. All of them are positive except for 1, but since we have 1, that's a counterexample, and that proves this statement false. Number 3, every prime number is odd. So again, if we start listing out the prime numbers, we have, sorry, I'm moving my marker. We have 3, we have 5, we have 7, we have 11, we have 13, etc. So all of these numbers look odd. Were you able to come up with a prime number that wasn't odd? Well, again, I conveniently left a number out. I left out the number 2. 2 is the, if we think back to the definition of a prime number, it means that it only has 2 factors, 1 and itself. So 2 only has 2 factors, 1 and 2, but it is even because it is evenly divisible by 2. So this statement is also false because we just found a counterexample. And number 4 says any 3 points are coplanar. So coplanar just means all 3 points will lie on the same plane. This is true. By definition, a plane is determined by 3 points. So if you choose any 3 points in space, you could always draw a plane between them. It's kind of like a line. A line is determined by 2 points. If I put any 2 points in space, you can always draw a line through them. So a line is determined by 2 points, a plane is determined by 3. Okay, let's get into the material for today. So we have a bunch of statements here. We're going to read example 1 first. It says, if it's 90 degrees outside, then Derek's dad will take him to get ice cream. Then I give you 4 different ways of rewriting that statement. Not necessarily in the same way, but just I changed some words which may change how the statement is taken. So number 1 says, it's 90 degrees and Derek's dad takes him out for ice cream. Number 2, it's 90 degrees, but Derek's dad does not take him out for ice cream. Number 3, it's not 90 degrees, but Derek's dad takes him for ice cream anyway. And number 4, it's not 90 degrees, and Derek's dad does not take him for ice cream. So given the original statement, the one in bold, which of these other 4 statements seems to not fit with the original statement? So we're going to assume that this first statement is true. So if this is true, which statement here doesn't quite seem to fit? Okay, write that statement down. If you want to also go ahead, you're going to do the same thing with example 2. So you're going to try to rewrite the initial statement right here. You're going to rewrite that in the same 4 ways that I wrote these statements up here. Okay, and then you're going to see, okay, which one of those doesn't fit with the original one, and answer why. And then you'll come back here and we will quickly discuss. Okay, so if the first statement is true, what that means is that if the temperature is 90 degrees outside, then Derek's dad will take him to get ice cream. Okay, so if it's 90, he is going to get ice cream. That's true. The first one makes perfect sense. It's 90 degrees, and Derek's dad takes him out for ice cream. We would expect that to happen. The second statement says it's 90 degrees, but Derek's dad doesn't take him for ice cream. Well, if we know the bold statement is true, then number 2 doesn't really make that much sense, because if it's 90 degrees, we know that Derek has to go get ice cream, right? That's given based on what the bold statement says. Let's see if there's any others that don't make sense. Number 3 says it's not 90 degrees, but Derek's dad takes him for ice cream anyway. Does this make sense with the bold statement? So all the bold statement says is that if it's 90, then he's going to get ice cream. It doesn't say anything about the fact that, it doesn't say anything about what happens if it's not 90, right? Derek's dad could be nice and go get him ice cream anyway. And that doesn't mess with the truth value of the bold statement. It doesn't go against what the bold statement says. So number 3 is okay. Number 4 says it's not 90 degrees and Derek's dad doesn't take him for ice cream. Well, this is perfectly fine given our bold statement. The bold statement only says that if it's 90, he's going to definitely get ice cream. So if it's not 90, Derek's dad has no obligation to go get him ice cream. So each of those statements works except for number 2. It goes against what, that's not how you spell against what initial statement said. Okay, all the other ones, numbers 1, 3, and 4, they could all be true based on what the bold statement said. But if number 2 was true, then it would mean that our bold statement wasn't true. And we said that was true to start with. Okay, let's look at number 2. One different example, but we're going to do the same type of idea. I'm going to put these up onto the screen rather than write them out to save time. All right, so I bolded our original statement again, just like for example 1, and then I wrote out the 4 similar statements. So if the team is up by 2 goals, then Kylie will get subbed into the game. Again, we are taking this statement to be true. And now we need to figure out which one of these other ones doesn't seem to make sense if we know that bold statement is true. So number 1 says the team is up by 2 goals and Kylie goes into the game. Well, that's what the original statement said was going to happen if the team was up by 2 goals. So we're okay there. Statement number 2 says the team is up by 2 goals and Kylie does not go into the game. So again, we run into a problem here. If the bold statement is true, then we know Kylie has to go into the game if they're up by 2 goals. But number 2 says that she doesn't go into the game when they're up by 2 goals. So this doesn't make sense. Number 3 says the team is not up by 2 goals and Kylie goes into the game. Well, the bold statement doesn't say anything about what happens if the team is not up by 2 goals. So we can't say that number 3 doesn't make sense because the team isn't up by 2 goals. So Kylie could go into the game, she could not go into the game. Number 4 says the team is not up by 2 goals and Kylie does not go into the game. So again, because the team is not up by 2 goals, it doesn't matter what happens to Kylie, right? The only thing that we know for sure was that if the team was up by 2 goals, then Kylie would definitely get into the game. So again, same idea from example 1. Number 2 just seems to go against what our bold statement was saying to begin with. So you may be wondering, Mr. Fawcett, why'd you make me write out these statements? Why are we just switching some words and seeing whether it makes sense or not? Well, as you'll see in a second, there's different kinds of statements, and sometimes changing one word will change the entire truth value of that statement. And then other times it does not. So again, just this way of thinking is a little different, right? Usually when you step into a math class, you're asked to solve an equation or look at a word problem. But here, we're looking at the truth value of statements. We're trying to determine whether these statements are true or false, whether they make sense or not. So it's a little different. I'm trying to not have us just jump into the pool immediately, but kind of wade in and get our feet wet so that everything isn't thrown at us at once. Okay, let's move on to the next page. Let's do some vocab. So a conditional statement. This is a statement that can be written in the form if P, then Q. And symbol-wise, this little arrow just represents then. So if we start out with something, then something else must happen. So an example of a conditional statement would be if Jasmine wins her basketball game, then her family will go out for dinner. So the P part of this, right, is if Jasmine wins her basketball game. That's the P. The Q portion would be then her family will go out for dinner. So if she wins the game, then her family will go out for dinner. The P part is called our hypothesis. And this will follow the word if. Now, they may not always put the word if in a conditional statement, but if they do, then the hypothesis is directly after the word if. The P is also what represents our hypothesis. So above, we already did this. So you could copy down, oops, let's do blue, so it's the same. You could just copy down this. Oh my goodness, still my eraser, I guess. There we go. So you could just copy down the P part for our hypothesis right here. The conclusion is the Q part, and this will follow the word then. So we already identified what our Q was here, so that would be our hypothesis, and that's what you could write down there. So conditional statements, there's an if part, there's something that comes first, and then there's a then part. There's something that is dependent on the initial thing, right? So Q depends on P. So sometimes a conditional statement may not include the words if and then. Sometimes it may include one of them, sometimes it may include both, but sometimes it may not have either of them in the statement. Sometimes the conclusion may come before the hypothesis in the statement. It's kind of up to you to determine which is the hypothesis and which is the conclusion by determining which relies on the other. So the conclusion relies on the hypothesis. Right? You don't start with a conclusion and backtrack your way into a hypothesis. You start with a hypothesis. You could think about science class. If you ever run an experiment, before you run the experiment, you come up with a hypothesis. You write down what you think is going to happen. Then you test that and by setting up an experiment. And then at the end, you write your conclusion. Right? You don't write your conclusion and then run the experiment, right? And then write your hypothesis. You do a hypothesis, experiment, conclusion. Same thing with conditional statements. So let's look at these three conditional statements here. What I want you to do is just underline the hypothesis. So take some time, pause the video, come back once you've underlined something from each statement. Okay, so for number one, it's nice because it is in the form if-then. So if a butterfly has a curved black line on its hind wing, that's our hypothesis, then it is a viceroy, which would be our conclusion. So being a viceroy depends on having a curved black line on its hind wing. Number two, a number is an integer if it is a natural number. Now, here, the if comes in the middle of the statement, so our hypothesis is actually second. Number three, the fact that it's raining outside implies that your driveway is wet. Here they don't give an if and they don't give a then. So it's up to us to decide which relies on the other. Well, let's think about it. We have two options for our hypothesis. We have the fact that it's raining outside, and we have implies your driveway is wet. Well, which relies on the other? Does the fact that it's raining rely on your driveway being wet? Does it only rain if your driveway is wet? Does the rain care if your driveway is wet before it starts to come down? No, it doesn't, right? But your driveway being wet is dependent on whether it's raining, right? Or it relies on the fact that there's rain. So here, our hypothesis is that the fact that it's raining. Okay, I think we're going to stop the video here. I think we're almost at 20 minutes. So we will come back for a part 2. We'll look at some more conditional statements. We'll practice writing our own conditional statements. And then we'll also look at how we can rearrange the conditional statements to come up with similar yet possibly different statements, just like we were doing in our first examples with Derek and getting ice cream, and our second example about, I'm blanking on the name that we came up with. Let's just look real quick. It was Kylie going into the game. So I'll see you for part 2, hopefully. Until then, enjoy the rest of your day.